Hello and welcome everyone. I'm Sam Turner, Key Account Manager for the Industrial Aftermarket in the UK at NTN-SNR. Today I would like to introduce to you our hot mounting solutions. Let's start this presentation by detailing the main causes of bearing failures. Lubrication issues account for 55% of premature failure. Pollution problems in 16% of cases. Poor assembly is the root cause 17% of the time. An overload problem in 6% of cases, and various other causes account for 6% of failures. As we can see in this graph, the importance of the number of failures linked to poor assembly has led NTN-SNR to develop simple and easy to implement solutions to mount bearings more reliably and safely. So, why is the mounting of bearings so important? I'm going to present below some examples of bearing damage linked to poor assembly practice. We can see in this image a cage which was deformed during assembly, shocks caused by incorrect use of a mass, most likely a hammer. Let's continue with an example of force fitting an outer ring on the rollers. On this image we see spalling, which is linked to an axle overload generated during assembly. On this one we can see a total destruction of the bearing, which is linked to a total elimination of clearance during assembly. And finally, in this image we see a defect linked to repeated axial forces induced during assembly. We will now talk about the key points to consider when fitting bearings. First rule, the bearing must have a tight fit on the ring that rotates. For example, an electric motor, the bearing will be tightened on the inner ring. Second rule, the fitting is performed on the ring of the bearing which has the tightest fit. And additionally, remember to add mounting paste when installing the bearing. It will prevent contact corrosion and facilitate dismantling. Now, let me tell you about the different fitting techniques. To start, the assembly on a cylindrical shaft. For small diameters, we can use a cold assembly case. For larger diameters, above 80 mm, the bearing must be heated to facilitate its expansion. NTN-SNR recommends the use of an induction heater. For mounting on a tapered shaft using an adapter or withdrawal sleeve, we recommend the use of a hydraulic nut, which is particularly useful for fitting spherical roller bearings. We will now talk more specifically about hot mounting. Why is this technique used? Heating the bearing allows the inner ring to expand, promoting effortless assembly of the bearing on its shaft. Remember, when increasing the initial temperature of an inner ring by 100 degrees Celsius, the diameter of this ring will expand by 0.1 millimeters. Now let's take a look at the different heating methods. I will firstly tell you about the methods to be avoided. A torch or a heating plate should not be used. These two methods do not allow us to control the temperature, so there is a strong risk of overheating, leading to the expulsion of the bearing grease and probable deformation of the materials. Moreover, these methods can be dangerous for the user. Sealed bearings cannot be heated using this method. Another method to be avoided is the oil bath. Its heating process is slow, there is a risk of introducing contamination, can be dangerous for the user and bad for the environment. Again, this method is not suitable for sealed bearings. We also recommend avoiding using an oven to heat bearings. The process is very slow, consumes a lot of energy and can result in grease leaking from the bearing. Therefore, seal bearings cannot be heated in this way. I will end with the method recommended by NTNS-snr, induction heating. It preserves the integrity of bearings. It prevents any material deformation. It is speed and energy efficient. All this in complete safety for the user, and of course seal bearings can be heated using this method. Let me detail the range of NTNS-snr heaters. Let's have a look at the principle of induction heating. A coil is placed on a steel frame which creates a magnetic field. The bearing placed on this frame becomes a secondary coil in the circuit. Crossed by an alternating high current at low voltage, the bearing will heat up quickly while non-metallic parts and the appliance itself remain cold. I will now introduce our Smart Temp induction heater range. The range consists of 7 devices that can heat parts ranging from a few grams up to 1600 kilograms. We start with the Smart Temp S, which can accommodate components up to 50 kilograms, the Smart Temp M up to 100 kilograms, and the Smart Temp L up to 200 kilograms. For freestanding devices, we have the Smart Temp XL, which can support 400 kilograms, the Double XL up to 800 kilograms, and finally the Smart Temp Triple XL, which can support loads of up to 1600 kilograms. All our devices are equipped with an intelligent interface and innovation to obtain maximum efficiency for the component to be heated. Now let's detail the innovative functions of our new induction heaters. The mode timer, which allows repetitive use of the device on a production line. Temperature mode with a probe, ideal for heating a non-sensitive part. This function allows a time reduction of up to 30% compared to conventional devices, and also a reduction in energy consumption. The 2-probe temperature mode, an innovative function heating a bearing intended for sensitive equipment in the best possible conditions. The ramp mode, with preset temperature and time. This function allows pinions to be heated with the most efficiency. I will present the benefits that these different functions offer to the user. Firstly, a reduction in operating costs by optimizing the heating process of components such as bearings with the 2-probes mode or pinions via the ramp mode. Their service life can be maximized. Secondly, improved efficiency with a device designed for intensive use that can heat solid parts as well as bearings of the same weight while consuming less energy. Finally, easy to use thanks to its touch screen. The configuration and monitoring of the heating mode has never been so simple. In addition, it is also possible to extract the heating data via a USB stick. On this slide, we will see an example of the gains made through use of an NTNS-snr Smart Temp. We were contacted by the maintenance department of a chemical components factory that was facing premature wear of pinions on a production line. Cause of this wear, use of a torch to mount the pinions, which had the effect of altering the heat treatment of the pinion teeth, causing its premature destruction. The annual cost generated by this premature wear amounted to €72,000, including €60,000 for machine shutdown and €12,000 for maintenance costs. Our solution, the use of a Smart Temp M to heat the pinion in the best possible way thanks to the function ramp. Gains made by the customer, €3,000 on maintenance and €40,000 for machine availability, a total of €43,000. The documentation relevant to this presentation can be found on our website under the documentation section. A tutorial is also available on our NTNS-snr YouTube channel. explaining how our products work. So, this brings me to the end of this presentation. Once again, thank you for your attention. Coming soon, our next masterclass. Please join us when we will present NTN Deep Groove Ball Bearings.